This is the AND gate schematic. We have our switch 1 and switch 2 as our A and B inputs, connected to two NPN transistors, and then our LED is our output. This is the AND gate symbol in the truth table. You can see for 0, 0, it's 0, for 1, 0, it's 0, for 0, 1, it's 0, but for 1, 1, the output is 1. Okay, so here's the SparkFun AND gate. You can see both inputs are set to 0 here, and there is no LED on the AND gate. If we turn one LED on, or one switch on, still nothing. But if we turn the other input on and they're both set to 1, we get this little LED here. And here's the AND gate circuit. We have our two A and B inputs here, and our output is the LED. You can see if we hit either switch independently, nothing happens to the output, it stays at 0. But if we hit both switches at once, the output goes to 1. Now, a real-life application of a NAND gate, say you have a security system with a master switch to turn it off, on and off, and say this switch here is a motion detector. If this switch is off and the motion detector gets something, nothing will happen. But if this switch is on and then the motion detector detects something, you get the alarm to sound. This is the NAND gate schematic. We have our two input switches, S1 and S2, connected to our NPN transistors. Up here is the output, our LED, that goes towards ground, and the voltage that feeds it comes in through this resistor. This is the NAND gate symbol, and this is the NAND gate truth table. You can see the output is 1 for these three here, but if both inputs are equal to 1, then the output is 0. Now this is the SparkFun NAND gate. You can see right now both inputs are set to 0 and the gate is on, so the output is 1. If we turn one input to 1, we continue to have this gate be active. Now the same would happen if we turn this switch on, but if we have them on and both set to 1 at the same time, you can see the output here is 0. This is the NAND circuit. You can see currently this LED as our output is equal to 1, and our switches A and B, if you hit them independently, our output is still equal to 1, but if you hit them simultaneously, our output goes to 0. So a real-life application for a NAND gate, say you have a very sensitive system that you don't want to be accidentally shut off. You can use a NAND gate so that if someone accidentally turns it off in either spot, nothing happens. You need to have both switches off for the output to go to 0. This is the OR gate schematic. We have our two input switches A and B right here, connected to the NPN transistors, and the emitter of these transistors goes straight to ground, so that if either of the buttons are pushed, it will turn on this LED because the current flowing from this voltage source here is able to go through the LED and pass into ground. This is the symbol for the OR gate. We have A and B are inputs and our output Y. And right here is the truth table for the OR gate. You can see for 0, 0, the output is 0, and for the rest of them, the output is on because the current can flow through the output. And here's a little SparkFun gate. You can see that both switches are set to 0 and there is no LED. If you turn one on, there's an LED. Same with the other one there, and for both, the LED stays on. Now right here you can see the circuit. Our two switches A and B, and then our LED output. You can see if we hit either one, the LED turns on, and same if we hit both. Now a real-life example for the OR gate is a doorbell system in a house. Say you have two doors and a doorbell at each, and we'll call this LED our doorbell. You want the doorbell to go off when either of them get hit. And you can see that that is how it works. This is the NOR circuit schematic. Right here we have S1 and S2, that's our A and B inputs. They're connected to NPN transistors. Up here is our LED, that's our output. This is the symbol for the NOR gate, and this here is the truth table. You can see that for 0, 0, the output will be 1. For 1, 0, it will be 0, 0, 1, it will be 0, and for 1, 1, it will be 0. Here's the spark fun for the NOR gate. You see that currently they're both set to 1, and it's not, the LED here isn't on. If I turn this one up, still not on. Turn that one up, not on. If they're both set to 0, then the LED turns on. And here is the circuit. You can see our A and B inputs and then our LED output. The LED is currently on because both switches are 0, but if I hit either switch, the LED turns off, and if I hit both switches again, it turns off. Now, a real life use for a NOR gate is, say you have a machine running here that you want to be able to stop from multiple places. You can hit either of the kill switches and it stops the machine immediately.